Till now we have talked about Docker. Okay, so we have seen how to build your Docker images, what are the options you there, and then we talked about microservices and how to deploy the Dockerized application onto Kubernetes, and we have seen all the options available there. Okay, so to complete the automation cycle, right? So I will not be able to manually run these Docker images and then build it and push it to a centralized repository. From there, attaching it to the Kubernetes cluster. This is not going to really work in the manual way, because everything I want it to be automated. That's what microservice also insist. Okay, so that is where the continuous integration system comes into picture. Okay, as a developer, I'll be writing the application code and also the respective Docker file and the Kubernetes deployment files. I'll be writing them and storing that in my repository. Okay, and I want a system which can automatically take the code from the repository and automatically build and deploy the application. And while building and deploying the application, I may need to have multiple scenarios. Like I may need to run a unit test case and I need to publish the report. Okay, and after the build, I may need to do a code quality scan. Okay, and the public and based on the code quality, it should either pass or fail my deployment. Okay, and then next will be your functional testing. You may need to execute a functional test, and if the functional test is failing, you want to either proceed or pass this pipeline. Okay, and once everything is fine, it should deploy that application on my Kubernetes cluster. And in there, if there is any issue, I need to have my email notification enabled, or any notification mechanism. It should notify me about the particular job execution. Okay, these are all my requirements in my continuous integration system. Okay, so this is my requirement from the continuous integration system. So there are multiple continuous integration systems available in this world. Okay, so the most famous in this are like open source solution like Jenkins. Okay, rather than Atlassian suite, that is like your Jira, those components. They have a tool called Bamboo. Okay, they provide Bitbucket for storing the source code and Bamboo for code build. And like that, there are other tools like Travis, Circle CI. Okay, and also we have tools like these cloud providers also provide a similar set of tools like AWS DevOps and then Azure DevOps. So these are all the components which are available in the like continuous integration system. Okay, here we are going to talk more about Jenkins, because this is a very popular open source solution, and this is built on a Java. Okay, so it can run on any architecture. Like if you want to run it on a Windows based system, you can run it, or if it is a Linux based system, you can run it. Okay, and it works on a plugin based architecture. So when I talk about Jenkins, it has to communicate to multiple targets, right? It has to communicate to my Docker to build and deploy the Docker. It has to talk to my Docker registry to push and pull the images. Okay, and it has to talk to my Kubernetes to do the deployment. So all these things. So the Jenkins is designed in a way that it will have a core engine, and I am allowed to write plugins. Via the plugin, it will be able to communicate and give instructions to the respective system. Like if I want to communicate to Git, there is a plugin available for Git. If I want to communicate to Kubernetes, there is a plugin available for Kubernetes. So those kind of scenarios are available. Okay, so this is the core Jenkins architecture. Okay, and it basically started as a Hudson product. Okay, and before the product is completely ready, they want to take it as an enterprise solution. So there are some developers who still came out of that, and they still continue to have the Jenkins as an open source solution. Okay, and you can see reference for Hudson in most of the code. Okay, and Jenkins is available in both open source version and enterprise version. The basic difference you are going to get in the enterprise version is you will get a support, and also the high availability can be achieved in enterprise solution. Okay, so there is some concept of master of masters. Okay, in that way you can achieve high availability in the enterprise solution. So this is the basic definition. Okay, and if you see in the DevOps stages, right? So in a DevOps, when you talk about stages, multiple stages, you will have a Git, and then you will have your build stage, right? You will be automating the build using Ant or Maven, and then you will be doing your continuous testing using Selenium, and you will be doing the configuration management using configuration management tools like Ansible or Puppet. And then to do a continuous deployment, you will use tools like Ansible or anything. And then for continuous integration, continuous monitoring system, you will have some monitoring solution like Zabbix, Nagios, all those things. Okay. So Jenkins is going to sit in the middle and it is going to orchestrate the complete flow of it. Okay. So this is the typical architecture or typical situation where Jenkins will be the heart of the DevOps and all the other tools will be connected to each other via Jenkins. Okay. And what are the advantage of Jenkins? It is open source and it has a very great community support and it is very easy to install. It has nearly 1,500 plugins. Okay, this PPT is not updated. So it has nearly 1,500 plugins. Okay, and it is free of cost as it's open source and it is built with Java. So you can run it on all the major platforms. So what are the things Jenkins can do? You can associate Jenkins with your version control system. From there, it can automatically pull the source code. Okay. And for the pulling, it provides multiple mechanisms. You'll see all the examples. Like every 30 minutes, it can communicate to the source control management system and it can pull it. Okay. Or there is a concept called webhook. So whenever a commit has happened, Jenkins can receive webhooks from GitHub so that whenever I commit, it is going to automatically start a build. Okay. And it can communicate. You can execute bash script or shell script or PowerShell script from Jenkins. Okay, you can execute Ant and Maven builds, and you can trigger testing jobs in that. Okay, and you can create a sequence and pipeline things. Like for example, you want to say if the testing is successful, I want to proceed, or otherwise I want to stop it there. So those kind of things you can do it in Jenkins, and you can publish the results. So anyway, whenever you create a test result, it is going to create an HTML report or XML report. So it gives you an option to publish the test results. Okay, and it can trigger the continuous delivery systems like Ansible or Puppet or Kubernetes. Even Kubernetes can be considered as a continuous delivery system. It can trigger them and it can deploy the application there. Like that, you can do any number of things using Jenkins. Okay. And continuous integration system, we have discussed about that. Okay. So basically, what is the advantage of continuous integration system? So the developer doesn't need to wait for the operations team to build the application and put it onto the dev environment. So as this process is automated, developer is going to get more time in working on the code rather than following up on the tickets. Okay, and everyone can see what is happening, whether a build has been pushed or not. Everyone can see that, and the build can complete faster compared to the manual method. Okay, and he doesn't need to wait for, if there is an issue with the build, the developer is going to get that. Okay, so this is how a normal continuous integration system is going to look like. Developer checks in the code into the Git repository, so CI server will get that. Okay, and if there is any issues, it is going to revert it back to the developer. Okay, so this will be a normal typical scenario. So you have multiple developers who are putting it in a repo, and Jenkins is going to execute the test case. And if the test case is successful, it is going to put in the production server. If there is any, the build and test results will be shared to the developers. So this is the continuous integration system. Okay. So what is the how the complete flow is going to change before and after Jenkins implementation? Okay. So before Jenkins, the entire source code has to be built and pushed. But once the Jenkins comes in, every commit can be individually built and pushed to the target. Okay, and developer has to wait for the testing team to share the test result. But here, for every commit, the test will be executed, and he will be able to see the test cases. And there is no feedback present. Here we have a feedback mechanism available. Okay.